Okay, so let's do problem number 1. Convert the angle in decimal to degrees. (90°), 52 minutes, 19 seconds. Okay. So there are 60 seconds, 60 minutes in a degree. And so there are 52 minutes is 52 60th of a degree. There are 60. Oh, why does this keep doing that? Okay. There are 19 seconds. Again, there's 60 seconds in a minute. And 60 minutes in a degree. And so let's do that. So it is 90 plus 52 over 60 plus 19 over 60 squared. Well, let's first write that as a fraction. Oh, that's a large fraction. So it is 32, 71, 39. 39 degrees, which is approximately 90.8719. Oh, well, maybe I'll do it. So 90 90.87194. Okay, good. Degrees. With fours keep repeating forever. Oh, that's A. B. Find the length of the arc of a circle whose radius is 9.6 inches, subtended by a central angle that measures 315 degrees. There are pi radians in 180 degrees. Okay, and so let's do that. So it's 9.6 times 315 over 180. So 84 over 5. And so this is 52.77. 75658. And these are inches. So around 53 inches. C. Find the area of a sector of a circle of radius 7, subtended by a central angle of measure 75 degrees. So you have to multiply by pi over 180, and then 7 inches. So 7 squared. Okay, so let's see what that is. So 1/2 75 pi over 180 times 7 squared. Okay. $12.25 over 12 square feet. $320.704. 2501 square feet. Okay. 2. The blade of a windshield wiper sweeps at an angle of 135 degrees in one cycle. The base of the tip is 12 inches from the pivot point, and the tip is 32 inches from the pivot point. What area does the windshield wiper cover in one cycle? Round the answer to the nearest 0.1 square inch. Okay, so the area is 1/2 theta r squared. So it's 1/2 theta, which is 135 degrees times pi over 180 degrees to make this into radians times a radius, which is 32, is the outer one, minus, well, 1/2 135 degrees pi over 180 degrees. The base of the blade is 12 inches from the tip. So times 12 squared. Okay. So this is equal to 1/2. Of course, I can just subtract those, but 1/2 times 135 over 180 times, this is 32 squared minus 12 squared. 330. pi square inches. Okay. Which is approximately 1,036.725576. To the nearest 0.1. 1,036.7 square inches. Okay. So that's the approximate amount. 3. An object is traveling around a circle with a radius of 10 meters. If in 15 seconds, the central angle, of 3 radians is swept, what is the linear speed of the object? Okay. So I have here something that's rolling, and it's gone here 330 3 radians. Okay. In 15 seconds. Okay, and the radius is 10 meters. So the radius of that is 10 meters. Well, speed is equal to distance over time. And the distance here is, well, how far you've traveled, which is what we have up here. So maybe I should call it, well, I'll call it S, because that's the distance that you've traveled, which we know is r theta. And so the radius is 10 meters. The radians is 3. The time is 15. And so this is 2 meters per second. Okay. An object is traveling at 50 miles per hour. Okay. speed is 50 miles per hour. If the diameter is 26 inches, so that means that the radius here is 13 inches. Oh, it's in miles and inches. Express the revolutions per minute. Okay. Now, so the distance is r theta. So let's figure out in 1 minute how far has it gone. Okay. Because it's revolutions per minute. Okay. So the distance is 50 miles in 1 hour. There are 5,280 feet in 1 mile. There are 12 inches in 1 foot. There are 60 minutes in 1 hour. Okay. So let's see what this is. Okay, so multiply that. Obviously, you can cancel some things out. That becomes 5, and so this becomes 10. Okay. Okay. Oh, so that's not too bad. Okay. Oh, because it's 50 miles per hour. That makes it good. And so this is 52,800. The miles cancel, the feet cancels, the hours cancel. And so this is inches per minute. Okay. So that's the speed, the velocity. I didn't say what this was. So this is the velocity that you're going, the 50 miles per hour. Written in inches per minute. Okay. So that's what your velocity is. And so note from above, the velocity over the radius is, well, maybe I'll write it this way. The radians per minute, or the revolutions per minute. Let's do it in revolutions. The revolutions per minute is just, well, again, I'll which is, just a rescaling of the radians per, the radians per unit of time is just the velocity over r. And so that is 52,800 over, and that's inches per minute. Inches is 13. Okay. And this gives you radians per minute. Okay. But I want to do this in a revolution. There are 2 pi radians in 1 revolution. Okay, so let's do, that's 2 pi. So let's do that. So, 52,800. Obviously, divided by 26. See if I can. No, it's not. Of course not. You can of course do that over 13. Yeah, whatever. 52,800 divided by 2 is 26,400. Over 13 revolutions per minute. So 26,400 times pi divided by 13 is 63.79. I think there was an 8.4, but I'm not sure. 63.79. Yeah, 63.79, 84, 96.97. Revolutions per minute. Rounded, and they say round to 2 decimal places. 8.5. RPM 6379.85. So approximately 6,379.85 revolutions per minute. Okay. 4. A point of the angle of the terminal size. Okay, so we're at 3, -4. Okay. Express the, so let's say theta is here. A. And of course, this is going to be 5 because this is a 3, 4, 5 triangle. Find the exact value of sine and so it is opposite, or let's say this is the point xy, and we know what r is. R is 5. And so this is just y over r, which is a negative 4/5. B cosine, which is x over r 3/5. C tangent, which is y over x negative 4/3. D cosecant theta, which is r over y, which is negative 5/4. E secant, which is r over x. Oh, they didn't do cotangent. R over x, 5/3. Okay, problem 5. Name the quadrant. Cosine is negative. Cosecant is negative. So both cosine and sine are negative, so you're in the third quadrant. Cosecant is positive, so that means sine is positive. Secant is positive, so that means cosine is positive. So both sine and cosine are positive, so you're in the first quadrant. Tangent is negative, and sine is positive. No, sine is negative. So tangent is negative. So tangent will be negative when both x and y have opposite signs. So in the second and fourth quadrant, sine is negative in the third, fourth quadrant. Y is negative in the third and fourth quadrant. Therefore, it's in the fourth quadrant. Okay. Six. Find the exact values of theta. Cosine is 15/17. and you are between 3 pi over 2 and 2 pi, meaning that you are in the fourth quadrant. Find cotangent. Okay, so I have 15 cosine 15 over 17. Was it 8? I don't know. Let's do this. So a squared plus b squared equals c squared. Uh, 15 squared plus x squared equals 17 squared. 225 equals 17 squared. 289. So 289 minus 225 is 64. Oh, I am right then. So x squared is 64. So x is 8. Good. Okay. So therefore, cotangent theta. And so cotangent, well, first off, since we're in the fourth quadrant, cotangent will be negative. Next, cotangent is just adjacent over opposite. And so, negative 15 over 8. B. Cosine is 4 over 9. Tangent is less than 0. And so it's either, well, I don't know how to, it's either in the second or the fourth quadrant. But cosine is, it says tangent is negative, but cosine is positive, so it's in the fourth quadrant. Because that's the only way that tangent could be negative, if it's here in the fourth quadrant. Question. Oops. Oh, okay. Sorry about that. Yes. Okay, so you're in the fourth quadrant, so that tangent is negative. I want to find sine of theta. Okay, so first off, that's some reference angle. I have a 4, 9, 16 minus 81. 81 minus 16 is 65. So this is rad 65. Okay. And so I want to find sine. Sine is going to be negative. So sine theta is negative. And I want sine. So it is rad 65 over 9. And that's your answer. Oh, number 5. Okay, so B. So sine is positive. No, it's the first quadrant. Because sine is positive and cosine is positive. So they're both positive, so it's got to be in the first quadrant. So yeah, it has to be in the first quadrant because both sine here is positive. If cosecant is positive, so sine, because it's just a reciprocal of sine. And since secant is positive, cosine is positive because again, secant is just the reciprocal of cosine. So both sine and cosine are positive. So that's why it's in the first quadrant. Okay. Oops. I can scroll down, right? Hopefully. Oops. Okay. Let's do. Wait, where am I? Oh, here I am. Let's do problem 7. Secant arcsine -4/7. Okay. So let's define theta so that sine of theta is -4/7. Then I want to determine secant of theta. Okay. So I'm going to assume that we have defined this the usual way. And so I'm assuming that theta is in quadrant 4. Since the sine of theta is negative. So I'll assume that this implies that theta is in quadrant 4. And now let's draw this. Again, some reference angle. Be sure I wrote the right angles there. Okay. Of course, these all, yeah, just in the last one I didn't write a right angle. Of course, this is all right angle trigonometry. So I have sine is 4/7. 49 minus 16 30 is 33. So radical 33. So 33 plus 16 is 49. Okay. So secant theta. In the fourth quadrant, cosine is positive. So secant is positive. And so secant is 7. The hypotenuse over the adjacent. And just in case you want to rationalize the denominator, even though I don't like rationalizing denominators, I'll write it this way. So 7 rad 33/33. And that is your answer. Because that's what they do in high school. Okay. 7. Oh, that was just A. B. Cosine. Inverse of cosine 7 pi over 6. Okay, so let me just check. So cosine look something like that. And so usually we define the inverse cosine just in the first and second quadrants. 7 pi over 6 is in the third quadrant. And so we're going to have to put this into the second quadrant. And so 7 pi over 6 and 5 pi over 6 give the same cosine, the same value of cosine. Okay, so if you actually went here, 7 pi over 6 and 5 pi over 6 give you the same answer. And so that gives you the answer in the correct quadrant. And so this should be 5 pi over 6. Normally, cosine inverse of cosine of an angle would give you the exact same amount, but that's only if it's in the correct quadrant. In this case, since we're restricting our quadrants in the normal sort of fashion of restrictions for this for a precalculus class, then we would restrict it to the cosines to the first and second quadrant. So your answer is 5 pi over 6. Problem 8. Cosine arctan of u. Okay. So let's draw a little picture here. So tangent of theta should be u. So this is just radical 1 plus u squared. Question. Yes, trigonometric expressions are for right triangles. Okay, so we want to figure out the cosine. So the cosine of tangent inverse u is 1 over rad 1 plus u squared. So it's adjacent over hypotenuse, which I guess I'll write as 1 plus u squared over 1 plus u squared. And that's your answer. B. Sine of cosecant inverse u. And again, I'm assuming that u is nice. Okay, so let's do this. So I have cosecant so cosecant of theta is u. So this is u squared minus 1. And so sine of cosecant of u is just 1 over u. C. Tangent arcsine u. Okay, so let's draw that. So I have that sine of theta is u. And so tangent of arcsine of u is opposite over adjacent, which is u rad 1 minus u squared over 1 minus u squared. And that's your answer. Nine. Graph the function. Y equals sine. Oops. Two x minus pi. Okay. So the amplitude here is going to be 5. The period will be pi. So let's do this. Two, 4, 6. 2, 4, 6. Okay. I want to do a pi. Let's say that this is pi out here. Maybe I should go. I think I didn't quite put them the same distance. Okay. Now that one's off. Okay, that's not too bad. Okay, good enough. So at 0, it's 0 at multiples of pi over 2 at pi over 4. Let's do 3 pi over 4. Uh, so let's pi over 4. Yeah. So at pi over 4, that's going to be 2 pi over 4. 3 pi over 2. That's pi over 2. And so that'll be 5. So at 3 pi over 4, if you plug in, that's 3 pi over 2 minus pi is pi over 2. Sine of pi over 2 is 1. And so I'm here at 5. And of course, I didn't hit 5. There it is, 5. At pi over 4, that's going to give you minus pi over 2, which is a negative. At negative pi over 4, that's a negative 3 pi over 2, which is 5. At negative 3 pi over 4, that's a negative 5 pi over 4. Negative 5 pi over 2, sorry. Negative 5 pi over 2, which is a negative 5. And so let's see if I can do this. Except for this one, it's not very good. Why can't I do it over here? Maybe I need to restop. This should be the easiest one. I can't get it. Okay. Good enough. Okay, so I'll just make those bigger. Oh, I don't need to. I'll just get that out there. Okay. It says label the local maximums. These are local maxes. Label the local minimums. And the x-intercepts. Those are harder to. Maybe I'll just say x-intercepts. So those are all the x-intercepts that I had here. And show at least one period. I've shown more than one period. Okay. And that's what it looks like. Just looks like sine, basically. Yeah. It looks like sine, but it's just been squashed a little bit, basically. Ten. graph y equals secant 3x. Okay. Show at least one period. Label the vertical asymptotes. Okay. So secant is going to have a period of 2 pi, and so the period here is 2 pi over 3. So let's draw this. Okay. Maybe a few more. Do one more. Oh, there. Yes. What? 2 in front. Oh, there's a 2 in front? Oh, not that it really matters. There you go. When I Yes, there's a 2 in front. Okay. That will just make a very small change to the graph. 2 there. 2 minus 2. Okay. No, I see. Okay. Hmm. Actually, I labeled that wrong. Hope I can draw this good. And this is pi over 6. 2 pi over 6. 3 pi over 6. And this is 3 pi over 6. 2 pi over 6. 3 pi over 6. Okay, so now let's see. At 0, secant of 0 is 1. And so y is 2. At pi over 6, 3 times pi over 6 is pi over 2. Secant of pi over 2, well, cosine of pi over 2 is 0. Therefore, secant goes to infinity. Positive infinity. At negative pi over 6. Secant, 3 times negative pi over 6 is negative pi over 2. Secant of negative pi over 2 is again infinity. So it should look something like this. Pi over 3, that's secant of pi over 3. Cosine, I'm sorry, 3 times pi over 3 is pi. Secant of pi, well, cosine of pi is negative 1. And so this is negative 2. And again, 3 times pi over 6, secant of that is going to be infinity. So, and pi over 2, 3 times pi over 2 is 3 pi over 2. Cosine of 3 pi over 2 is again 0, so secant is infinity. So it looks like this. Negative pi over 3. 3 times negative pi over 3 is negative pi. Cosine of negative pi is negative 1. And so 2 times negative 1 is negative 2. Again, secant of 3 times negative pi over 6 goes to infinity. 3 times negative pi over 2 is negative 3 pi over 2. Cosine of negative 3 pi over 2 is 0, so secant is infinity. So we have this. They're, of course, approaching the asymptotes. And that's what secant looks like. What 2 secant 3x looks like. Any questions about that? Okay. Do you want to do one more of these? Um, let's see. You're up for going to finishing one more? Yeah. Okay, let's finish one more of these then. Okay, problem 1. Six cosine inverse 4x equals 5 pi. Okay, so that says that cosine inverse of 4x equals 5 pi over 6. And so 4x is equal to cosine 5 pi over 6. Okay, so first off, let's see. Five pi over 6 is here. So cosine will be negative. And let's see, this is pi over 6, pi over 3, 30, 60, 90 triangle. And so cosine is 1 over 2. So x is negative 1 over 8. And let me just check, see if I'm in the right quadrant. So that's a negative 1/2. So negative 1 cosine inverse of negative 1/2, and that's in the second quadrant. Yes, that is correct. Okay, let's do B. Find the exact value of cosine inverse sine negative 4 pi over 3. Okay, so negative 4 pi over 3, so xy. We're in the pi over 3. So that's negative 4 pi over 3. So we're in the second quadrant. Okay. Good. And so this is going to be pi over 3. So I can just look up here. So this is equal to cosine inverse of pi over 3 and that's going to be sine is positive. So it's a positive rad 3 over 2. Okay. Because you're in the second quadrant. And sine, the y values, are positive in the second quadrant. So now let's do cosine inverse of rad 3 over 2. So the cosine of pi over 6 is rad 3 over 2. So it's rad 3 over 2. Oh, you stupid. It's pi over 6. So it's pi over 6. Okay. And so that's the angle, such that cosine of that angle is rad 3 over 2. Problem number 2. Write the trigonometric expressions in algebraic expression in U. Also very similar. Tangent, sine inverse U. Okay, so I have theta, such that sine of theta is U. I wonder if this is the same thing we did before. So 1 minus U squared. And so this is equal to tangent is opposite over adjacent. And so this is U rad 1 minus U squared over 1 minus U squared. Let me just curious to see, did we already have this one? It looks so familiar. Yeah, it's that problem here. It's that we did have this. It's the exact same problem. Okay, but and luckily we got the same answer. Okay, so let's do B. That was A. B. Cotangent of arctan of U. And so I have here u tangent of theta is u, and so this is rad 1 plus u squared. So cotangent is, well, adjacent over opposite. So 1 over u. 3. Is the hypotenuse 1 plus u squared? Oh, 1, yes, it's 1 plus u squared. Because a squared plus b squared equals c squared. So 1 squared plus u squared is this squared, which is 1 plus u squared. Okay? For this one. Okay. 3. Solve the equation for sine squared minus 3 equals 0. So sine squared is 3/4. So sine theta is plus or minus rad 3 over 2. Well, we have that. Well, it's too high up. So let's do this again. Oh, pi over 6, pi over 3. 30, 60, 90 triangle. And so, and we're also so theta. And you only want theta between 0 and 2 pi. Okay, so let's see, positive. So you have to be in the, for the sign to be positive, you want to be in the first, or maybe I'll just sort of label it, in the first, second quadrant. And for the sign to be negative, you want to be in the third and the fourth quadrant. Okay. So sine, I want sine to be, and so it's pi over 3. That's in the first quadrant. In the second quadrant, the reference angle is pi over 3. So it's going to be a 2 pi over 3, pi minus pi over 3. The next one will have a reference angle again, a pi over 3. So that's a pi plus another pi over 3. So that's 4 pi over 3. And lastly, we want here reference angle of pi over 3. So it's going to be 2 pi minus pi over 3, which is 5 pi over 3. And those are the answers between 0 and 2 pi. 4. Cosine of 2 theta is rad 3 over 2. Those are all positive. All the angles are positive because we want the answer to be between theta to be between 0 and 2 pi. So you want all of your thetas to be positive and less than and less than 2 pi. Okay. solve this equation again between 0 and 2 pi. And so, well, I have this up here. And so I want cosine to be positive, cosine of whatever. So I'm just going to write what 2 theta is. And so I want cosine to be positive. So I want cosine to be in the first and the fourth quadrant. Okay. I want 2 theta to be in the first and the fourth quadrant. Okay, so I want cosine to be rad 3 over 2. And so cosine to be rad 3 over 2, meaning the adjacent of our hypotenuse. So the angle is pi over 6. But also, I want cosine to be positive. So it's also going to be in the fourth quadrant. So that's the reference angle is pi over 6. 2 pi minus pi over 6 is 11 pi over 6. I want it to be again in the first quadrant after I've gone a full circle, because I have a 2 theta here. So I'm going to have to probably go around the circle twice. So that's going to be once plus another pi over 6 is 7 pi over 6. And I want to go twice, but pi over 6 less. So that's did I make an error here? I want to go here, wait. Let me just, here, wait 1 second. There's something wrong with the 7 pi over 6. Okay, so I want to go, so I want to be here and here. Oops. Ooh, I'm doing it for the wrong, I'm labeling it for the wrong thing. So I want to be here and here. And so that's pi over 6. And then this is, 12 pi, 2 pi minus pi over 6 is 11 pi over 6. I want to go 2 pi plus another pi. 2 pi plus another pi over 6 is 13 pi over 6. Okay, that was my error. Didn't make sense before. Next, you want to go, so that's, you went in a full circle. And so now you want to go 1, 2 minus the pi over 6. So that's 4 pi over 6 minus pi, 4 pi minus pi over 6 is 24, 23 pi over 6. So therefore, theta is pi over 12, 11 pi over 12, 13 pi over 12, 23 pi over 12. And those are your answers for theta between, 0 and 2 pi. So those are the 4 answers in this case. Okay. Problem number 5. Here, 1 second. Problem number 5. Given the following equation, cosine theta equal rad 3 over 2. A, write all the solutions. So every solution, no matter what. And so let's see. Cosine is going to be positive. So we're going to use the same thing here. Oops. The same diagram here. Cosine is positive, so it's either going to be the first or fourth quadrant. So in the first quadrant, I want here cosine to be rad 3 over 2. Oops. Uh-oh. I'm sorry. I wrote it wrong. Negative. I want it to be negative rad 3 over 2. So it's in the second and third quadrant. I said it completely wrong. So it's cosine is negative. And so let's see. Cosine of pi over 6 is rad 3 over 2, the adjacent over the hypotenuse. And so the reference angle is pi over 6. So the first one is 5 pi over 6 plus 2 pi k, and this is for every value of k, which is some integer. Next, well, cosine is also positive in the third quadrant, so that is a reference angle of pi over 6. You go pi plus another pi over 6 is 7 pi over 6. And so all answers have the following form. Again, you just keep going around the circle a whole bunch of times. So A, it says here, write the general form for all solutions based on the smaller angle, the 5 pi over 6. B, write the general form. Write the general form for all solutions based on the larger angle. So that's what they mean by this notation. What is what's the upside? For every. For all. I was just being lazy, not writing the word. For all integers. Okay. There it is. Okay. 6. C. Right, the first 6 solutions greater than or equal to 0. Okay, so 5 pi over 6, 7 pi over 6, add another pi, 2 pi to that. That's 12 pi, so that's 17 pi over 6. 19 pi over 6, adding 12 pi. Adding 12 pi to this, you get 29 pi over 6, 31 pi over 6. So it says, list the first 6 solutions that are greater than or equal to 0. So that's the first 6 solutions. Okay, so all I did is I just kept adding 2 pi, which is the same as 12 pi over, is the same as 12 pi over 6 to each of these. And then for the next one, it'd be 24 pi over 6 that I'd add. 6. Use a calculator to solve 3 tangent plus 8 equals 0. So that says that tangent of theta is a negative 8 over 3. So theta equals arctan of negative 8 over 3. Okay, so let's do that in 0 to 2 pi. So tangent looks something like this. So tangent looks something, the graph of it looks something like this. Okay, so the negative of that will be in the fourth quadrant. If you look at the arctan. So theta, I'm going to have to do this on a, oops. Let's do this on a calculator. So arctan, and let's just check AM in radians. Okay. So I'm in radians, good. So negative pi, negative, so arctan of negative 8/3 is what I think it said. Negative 1.21, negative 1.2120 25657. Okay. So tangent of that will give you negative 8 over 3. Now, tangent will be negative in the first and the fourth quadrant. So you have to add, so if you add another pi to that, that should also, it did it here, so that gave it here. So it was in the first and the, oh right, because this gives it in the fourth quadrant. You can also have it in the second quadrant. So you can also have it over here just by adding pi to that. Oh, so maybe I should actually, maybe I should write it as also pi. So theta equals arctan There are two angles. There are two answers in 0 to 2 pi. Okay, so there are these two answers here. Oh, actually, I'm sorry, for this one, actually I should have written it the other way around. So they write this angle and this angle. Oh, so actually, since we want it to be, so we're going to have to write it this way. As this angle, and then as the negative of the other one. Maybe I'll write it this way then, because that will give you this angle here, which I should do 2 pi plus that, which will give you the other one. Ah. Because it's going to give it to you in the fourth quadrant, but we want it in the fourth quadrant going that way. And so I'm going to have to do 2 pi plus that angle, whereas the other one will be pi plus the angle. So actually I should write it this way then. Theta is, I should actually add 2 pi to that. Okay, that will give me that angle there, which is almost 6, okay. And the other one, the one with pi. And the pi. Oh, I should write the pi first, and then the 2 pi second. Just so that they go in order. Okay, and now let me do it with the pi. Okay. So evidently it clicks too much. Oh, come on. Okay. Having some problems with my pointer. Okay, so 1.9, 1.929, 1.929, 1.92, 1.929, 566. 997. So 1.9295, 9295, 66997, 667, 507, 11, 507, 11, 59651, 59651, 59651. Okay, and so those are your, it said, use calculator to solve this. Okay, so there they are. Those are your approximate answers between 0 and 2 pi. Seven. solve rad 2 cosine squared minus cosine theta equals 0. So I have cosine theta, rad 2 cosine theta minus 1 is 0. Therefore, setting each factor to 0, I have cosine of theta is 0, or rad 2 cosine theta minus 1 is 0. So I have that cosine theta is 1 over rad 2. And I want to solve this in 0 to 2 pi. Okay, so cosine will be 0 at 0 and pi. Next, I have a 45, 90-degree angle. And so, oh, maybe I should have put the, so there's a pi there. Actually, there'll be 2 of them before I get there, but okay. So cosine, is going to be here and here. Okay, so cosine is going to be 1 over rad 2 at pi over 4 and at 1, 2, 3, 4, 5 pi over 4. Wait, 1. There's a whole bunch more. 2, 1, 2, 3, 4, 5, 6, 7 pi over 4. 7 pi over 4. Or 2 pi minus pi over 4. And so those are your answers. So having cosine equaling a positive 1 over rad 2 or cosine equaling 0. Those are the answers between 0 and 2 pi. 8. Three plus 3 sine theta equals 2 cosine squared theta. Again, you're doing this between 0 and 2 pi. And so I have 3 plus 3 sine theta is 2. 1 sine squared plus cosine squared is 1 by Pythagorean's theorem. So cosine squared is 1 minus sine squared. Distributing the 2. Adding 2 sine squared to both sides of your equation. Subtracting 2 from both sides of your equation. Factoring. Setting each factor to 0. subtracting 1, dividing by 2, subtracting 1. Okay, so sine is -1. At 3 pi over 2. A 30, 60, 90 triangle. You have a 30, 60, 90 triangle. And so sine is 1/2. So that's pi over 6. And it'll be negative. In the third and fourth quadrant, sine is negative. So reference angle is, let's see, it's -1/2. So it's at 1/2, so it's pi over 6. So pi plus pi over 6 is 7 pi over 6. Pi over 6 is your reference angle, so that's 12 pi minus pi over 6 is 11 pi over 6. So those are the three answers, 3 solutions to that particular equation. Okay, 9. In that particular interval. 9. So given the following, sine is 7 over 25, where alpha is in the first quadrant. Okay, and beta is going to be in the rad 89 over 89, and beta is in the fourth quadrant. Okay, so I want to, I want sine of alpha plus beta. Okay, so it's going to be that cosine sine. Oh, it's imaginary. Okay, so it's cosine alpha sine beta plus sine alpha cosine beta. One of these days I'm actually going to memorize this formula. And so that's that I have to rederive it every time. But okay, so that's the addition formula for sine. So it says to find the exact value of sine of alpha plus beta. So this is equal to cosine of alpha. And so since, oh, I guess I have to draw a few triangles here. So for alpha, well, the reference angle for alpha, it's sine, so it's 7 over 25. I don't think that's a nice number. 25 squared minus 7 squared. 576. What's the square root of 576? 24. That's a 24. Okay, 24, 7, 25. That's a nice number. Okay, next. For beta, again, it's the reference angle for beta, not necessarily what beta is. This is going to be 8 over 89. 64 plus 15, 25. 64 plus 25 is 89, yeah. Okay, so it's 5. And so alpha is in the first quadrant. Beta is in the fourth quadrant. Okay, so cosine of alpha, that'll be positive. Cosine, and this is alpha, 24 over 25. Sine of beta, so sine is negative. And sine is 5 over rad 89 plus. And let me just check. Okay, so it's sine. Oh, it should have been written the other way around. It doesn't matter. Sine should have been written, I should have written that the other way around. Okay, so, but it's correct. Okay, sine of alpha, 7 over 25, and 8 over rad 89 is 7 times 8 minus 24 times 5 is 64. Negative 64 over 25 rad 89, which is a negative 64 rad 89 over 25 times 89. 2225. 2225. And that's your answer. Okay, B. Cosine alpha plus beta. So you do, it's cosine's a real part, so it's cosine alpha, cosine beta, minus, that's a plus, I squared, sine alpha, sine beta. Okay. Again, having to rederive this formula in my head because I can't remember it, is equal to cosine of alpha. I already did that. 24 over 25. Cosine of beta, 8 over rad 89 minus sine of alpha, 7 over 25, sine of beta, which is a negative 5 over rad 89. Is equal to, so you're going to add them. And so this is 24 times 8 plus 7 times 5, 35, is 227 over 25 rad 89, which is 227 rad 89 over 2,225. And that is your answer. Okay, 10. Tangent. Find the exact value of tangent, sine inverse, 12 over 13, plus cosine inverse, 1. Okay, so tangent theta, no, alpha plus beta is sine over cosine. Okay, so divide by sine cosine alpha, cosine beta. Okay, so this is equal to tangent alpha plus, I should write that the other way around, plus tangent beta over 1 minus tangent alpha tangent beta. Okay, so that's the formula that you were supposed to memorize. And of course, I don't memorize it. I always have to rederive everything because I don't memorize anything. Okay, so that's the formula. One of these days I'll memorize this thing. Okay, so this is, well, first, so tangent inverse sine 12 over 13 plus cosine inverse 1 is the tangent of arc sine 12 over 13 plus tangent cos inverse of 1 divided by 1 minus, same thing, tangent of this arc sine of 12 over 13. Tangent of arc cosine of 1. Okay, so this is equal to, let's do sine. So let's do some alpha, I guess, here, alpha. And so this is sine is 12, 13. I think it's a 5. 25 plus 144 is 169. So that's 13. Yep. So it's a 5, 12, 13 triangle. And then, so tangent would be 12 over 5 plus cosine of 1 is 0. You're not adding anything. It's cosine, our cosine of 1 is 0. Okay, and so it's 1 minus 12 over 5 times 0, which is 12 over 5. Did he really want that? Okay, so arc cosine of 1 is 0. Okay, so he's adding 0 to it. Okay, 11. If sine of theta is 3/4 and you're in the first quadrant. So theta is 3/4. 7 plus 9 is 16. Find the exact value of sine of 2 theta, which is 2 sine theta cosine theta. You just let each of these be thetas. And so this is 2 sine of theta is 3/4. Cosine of theta is rad 7 over 4, which is 3 rad 7 over 8. Cosine of 2 theta is cosine squared theta minus sine squared theta. If you just plug in, oh, there it is, alpha and beta equaling to theta. And so cosine squared, maybe I'll just do cosine, so rad 7 over 4 squared minus sine, which is 3 over 4 squared, is 7 minus 9, a negative 2 over 16. Negative 1 over 8. C sine theta over 2, which is rad if I just if I write this as cosine squared is 1 minus sine squared, this will be 1 minus, and let this be, yeah, so let this be theta over 2. Then this one, the theta be theta over 2. And write cosine squared is 1 minus sine squared theta over 2. Then you have that cosine of theta is 1 minus 2 sine squared theta over 2. And so sine squared of theta over 2 is 1 minus cosine of theta, and there's 2 of them, so that's divided by 2. And that's the sine squared of it, so it's got to be the square root of that. And we are in the first quadrant. So sine is in the first quadrant. If you take half of that angle, it's still in the first quadrant. So we're still in the first quadrant. So it's the square root of 1/2, 1 minus cosine of theta, but cosine of theta is rad 7 over 4. So this is the square root of, that's going to give you an 8. Okay. So this will be 4 minus rad 7 over 8. So this is going to equal bring out a 1/4 rad 4 rad 2 minus rad 14 in order to rationalize the denominator. You have to multiply and divide by rad 2 to rationalize your denominator. Doesn't look that good, but okay, that's your answer. D. Cosine of theta over 2. Well, that's, again, you'll still be in the first quadrant, so it's positive. Maybe I'll write it as 1/2, 1 plus cosine of theta, which is 1/2, 1 plus rad 7 over 4, which is 1/8. 4 plus rad 7. So again, you have to multiply by rad 2 to rationalize your denominator. So this is 1/4. 4 rad 2 plus rad 14. Unfortunately, you have square roots inside of square roots. Don't know if I can simplify that, but okay, 12. Sine 2 cosine inverse 12 over 13. Okay, so cosine 12, 13, that's got to be a 5. And so this is equal to 2 sine theta No, these are, well, these are just evaluating certain trigonometric values using the trigonometric identities. So these are uses of trigonometric identities, the double angle formulas and the half angle formulas. So you would look under half angle and double angle formulas and sum. So the sum formulas, which were the ones up here, these are the sum formulas. Uh, then the double angle formulas here, and then the half angle formulas here. Okay, so this is 2 sine cosine sine is just 5 over 13. Cosine is just 12 over 13. Is 120 over 169. 13. Oh no, I'm done. Yeah, that's it. Okay. Yeah, I think I want to end here for, oh, there's just one left, right? Yeah, I want to end here because I got to visit the restroom. So, okay, so when do you want to continue with the last one? Tomorrow? Sure, we'll do it tomorrow. Tomorrow's what? Saturday. Okay, so how about like 11 o'clock tomorrow? Okay, see you then. Let me save this.